This is lesson 41 on encoders. Now an encoder is just the opposite of a decoder. So remember, a decoder had n inputs and 2 to the n outputs. So an encoder has 2 to the n inputs and n outputs. There can often be an enable signal and also an output to indicate if it's a valid output. We'll see that. Here's an example of a 4 to 2 encoder. So it's 4 inputs and 2 outputs. So it's just the opposite of a decoder. So the idea is that only one of the inputs can be 1, either x0, x1, x2, or x3. That's the rule. And the binary output encodes which one it is. So if x2 is a 1, then the output is a 2. If x3 is a 1, the output is 3. So we assume only one input can be high at a time, either x0, x1, x2, or x3. In this case, the logic equations for y1 and y0 simplify because we don't need the entire min term. For example, y0 is 1 only if either x1 is 1 or if x3 is 1. So we can just say y0 is x1 or x3. Similarly, y1 is 1 if x2 is 1 or if x3 is 1. So this entire encoder just reduces to these two OR gates. y1 is just x2 or x3, y0 is just x1 or x3. Here is a 8 to 3 encoder, and again, only one output can be 1, x0 to x7. So the logic equation, for example, for y2 would be either x7 or x6 or x5 or x4. y1, looking at these ones, it's either y7 or x7 or x6 or x3 or x2, and y0 is either y7, x7 or x5 or x3 or x1. Here's an example of when you might use a binary encoder. This shows a sort of a wind detector to detect the direction of the wind. You see, you can think of this as a switch, so it closes the switch only at one of these places. In this case, only this output would be a 1, so the output 0, 0, 1 would tell you that the wind is in the northeast direction. Now, in general, we can have a priority encoder. That is, we can have more than one 1 on the input. But in that case, the one with the highest number has the highest priority. So for example, if x4 is 1, then we don't care if x3 to x1, they could also be 1s. The output would still be 4. If x0 is 1, you get 0. If x1 is 1, the output is a 1, no matter what x0 is. If x5 is a 1, the output would be a 5, and again, any of these x's, don't cares, could be 1s. x7 is the highest priority. That is, if it's a 1, then the output is 7, regardless of what all the rest of the x's are. So the question is, how can we write the logic equations for this priority encoder? Well, it's similar to what we had before, except that y2 we say is equal to L7 or L6 or L5 or L4. That is, it's these possibilities. But in this case, L7 is just x7. But now L6 is 1. Well, it's 1 if x6 is 1 and if x7 is 0. This must be 0 now. So we say not x7 and x6. Similarly, L5 is 1. X5 has to be 1 and x6 and 7, 0. So this is not x7 and not x6 and x5, and L4 is not x7 and not x6 and not x5 and x4. So that would be the logic equation for y2. There'd be a similar one for y1. Looking at these ones, you have an L7 or L6 or L3 or L2. L7 and 6 are the same as we had before. L3, for example, would be not x7 and not x6 and not x5 and not x4 and x3, and similarly for L2. And finally, y0 is L7 or L5 or L3 or L1. And L1, you see, all of these have to be 0 except 1, so it's not x7 and not x6 and not x5 and not x4 and not x3 and not x2 and x1. So those are how you find the logic equations for a priority encoder.